Let's look at example number 3, 2x over x plus 3 minus x over x minus 3 is equal to 3 over 3 minus x, right? Okay, so let's look at these examples now. 2x over x plus 3 minus x over x minus 3 is equal to 3 over 3 minus x. Right, so again we've got equations with fractions. We need to manipulate this using the LCD, and the LCD over here is going to be, well, these two look similar except that's x plus 3 and the other one is x minus 3, and the other one on that side is 3 minus x. So let's look at doing something with this such that it can look like that. And so what do? Well, we can write it, each of these is 2x over x plus 3 minus x over x minus 3. And we can take out a common factor of a negative here. And if I take out negative 1 there, I'm going to put the minus sign over here in blue, right? And then I can switch this around into x minus 3. Now why can I do that? Because now if I multiply negative with negative 3, I've got positive 3, and negative with an x, that gives me negative x. So now this and this is equivalent due to having the negative on that side, right? Okay, so now I can apply my LCD and I can say, well, the LCD is going to be each of these factors, x plus 3, x minus 3, and there's another x minus 3. But we only need to take it once. So in this case, I've got x plus 3, and I've got x minus 3, right? And since there's already an x minus 3 in the LCD, I don't need to include it again. Now I'm going to multiply each term by the LCD. So if you think of this LCD and you look at that first term, we put down the 2x, the x plus 3 cancels out with x plus 3, and I'm left with x minus 3. Okay, so then I've got x minus 3 over there. Then I put down the negative x, and I look at that, I've got x minus 3 in the denominator. I'm multiplying with this LCD over here, the x minus 3 cancels out, and I'm left with x plus 3. And now I put down the negative 3, right? I should erase this part over here. Okay, I put down the negative 3, the x minus 3 cancels with x minus 3, and I'm left with x plus 3 multiplied by that 3 over there. Okay, now there's something once again I left out here. When I was busy with the LCD, I needed to include a restriction, and I can clearly see that x cannot equal to, as part of my LCD, x, I have to put in this restriction that x cannot equal to negative 3, and neither can x equal to positive 3. Because if I insert positive 3 over here, that's going to be 0, and my entire equation becomes undefined. If I input negative 3 in here, this denominator becomes 0, and then again, my entire equation is undefined. Okay, so now we just multiply our things. 2x times x is 2x squared. That's going to give me negative 6x. That's going to give me negative x squared. Okay, and that's going to give me negative 3x. Multiply this over here is going to give me another negative 3x, and that's going to give me negative 9, right? And so now let's cancel out things. We can clearly see negative 3x's on both sides, so that falls away. 2x squared minus x squared leaves me with 1x squared. That's done. Okay, and then I've got negative 6x, and I've got positive 9 if I bring it over, and that is equivalent to 0, right? So now I can factorize. I can say factors of 9 I add to give me 6, and that's going to give me x and x. Remember, I must have equivalent to 0 over here. If that's not there, I cannot solve the equation. Both signs are going to be negative, and my factors are 3 and 3. And therefore, I find a solution that x is equal to 3. But now, remember, in this particular case, I had a restriction that I cannot make x equal to 3, otherwise my equation becomes undefined. And so therefore, x cannot equal to 3, and it was equal to 3 twice. I would say there is no solution, therefore. Okay, that's example number 3. Remember, the restrictions are incredibly important, because if we didn't put this in, we'd get a solution of 3, but 3 makes the entire equation undefined.